Welcome to Timber&Terra. I'm Glenn, and we are in the garage today. This video I think will be another sort of miscellaneous stuff. Might have a couple either repair fabrication projects similar to this one. I'm not sure. This is sort of the beginning of spring or end of spring, beginning of summer here in mid-May. So the ground is still mushy. There's not really a lot that I can do for dirt work. I have a lot of that sort of waiting to go. So in the meantime, I have some indoor projects and other things that I can do. So this one here is obviously a wood splitter. The throttle is here. The operator generally stands over there. And it's a bit sort of inconvenient, you know, if you're done splitting and you're, say, piling wood over there or something, and you just want to idle the engine. You have to walk all the way around here, and then if you want to start splitting again and you forget to rev it up before you head back over, you got to walk around or lean over here. So I bought this sort of general purpose throttle cable that I've clamped on there, thinking if I could control the throttle from over here, that would be a lot easier. So that's what I've done. I've taken or that's what I prepared for. I took the shroud off the muffler, which is right here, just to get a bit more access here. The air filter and housing off here as well. So this one here, this nut here is, it's not a nylock, but it has the same sort of features. I think it has actually a crimped end. So it threads on sort of tight onto the threads, but what it allows you to do is loosen this up. So that goes very easily now. Because if I was to not loosen this up, then I'd never be able to push that with the cable. Because this is idle, this is full throttle. So either way, either to go full throttle or to idle, I'm going to have to push it either way. So I figured I could mount this here somewhere and operate the cable here. So now this goes really easily. And because this is a nylock type nut or a self-locking nut, I'm not sure what the correct term is. It shouldn't loosen up anymore. Just sort of adjust it where you like to. The actual handle right here provides that same sort of resistance. So once you set it in a position, it's not going to move, even though we have like the spring. So if this is real loose, you can see here it's going to spring back because there's a spring there where my finger is and the spring here. So I think it'll work. I just got to figure out how to mount it. So I bought some hardware, a couple different pieces. So there's two ways that I could mount the cable. One way would be this, so I'd have to make two holes, one for the little nub and then one for some sort of a sheet metal screw to go in there. And I'm thinking that's going to be the best way, because that's what this is for. It's got a little detent there that'll sort of engage in the surface there of the cable. The other one here is sort of a generic cable clamp, which I'm just thinking this is not really that tight, even if I'd have to like wrap this with electrical tape. I just think this one is much more likely to loosen up, you know, go back and forth instead of hold the outer part of the cable in place. But the first thing I want to do is to mount this, because I think that's going to be a good spot. It's easy for the cable to go through here. It doesn't get in the way of anything. It's easy to access, even, you know, below this valve bank here. So it's got a couple mounting screws. What I think I'll do is drill and tap maybe some 1/4-inch bolts to fasten this on. I had thought of welding it, but I'd rather, if I can, use threaded fasteners instead of welding. I prefer to do that. Start with this one, so I don't have clearance for the other one. So I was not able, I don't have the right drill size for the 1/4 20. So it's a little bit bigger, so the threads will be a little bit looser, not as strong, but for this purpose I think I'll be fine. If for some reason these threads don't hold, then I'll just drill it out and put 5/16 in instead of 1/4 inch. Yeah, this would be pretty loose. Well, normally with a hole this tight, you wouldn't really need a washer, but I don't have full thread bolts here on hand, the way the thread goes all the way to the head, so I got to make up this gap here between the washer and the thickness of this plate so that the threads will go fully into the tapped hole where they need to. I'm sure I could very easily strip these by over torquing them, but that's good enough. So I disconnected the gas tank and just moved it out of the way because I need to drill this hole here. So there'll be 2 holes, a slightly bigger one for this little tab to fit in, and then I'll drill one for the sheet metal screw to go in there. So the final piece to this puzzle is how to attach this to the throttle. I came across this at my hardware store. Not sure what the name of it is, but it's a neat little contraption. That just presses against the wire there, the cable. It should. Well, with a screwdriver it will probably do a lot better. So I'm thinking I could drill some holes on either side of this and then sort of put this in the center. The other option is just to drill a hole here and then put this screw up through here, through the hole, but I'd probably have to get a longer machine screw or sand that down so this will have plenty of room to engage. So let me give this some thought and we'll come back. Well, now I feel like a fool. If I had looked at this more closely, I would realize it looks like they already have provisions for a cable. And this little doohickey that I bought does fit in this hole perfectly. It's almost like they were meant for one another. So yeah, I feel like a fool, but then again, this will be a better solution than what I was trying to do. But it wasn't obvious to me until I moved the gas tank. So I guess there's that consolation. Look at that, almost like it was meant to be. So this is idle. So the throttle will operate the opposite of what it did before. As far as all the way up is going to be idle now, whereas before all the way up was going to be full throttle. That was so nice and it works so easily. Well, it was so easily and it worked so nice, I guess is what I meant to say. Wow. That was nice. Okay, well, I'll put the gas tank back on and move to the next project on this. Boy, I'm very happy with that. I should have done this when I first got it, I guess 3 years ago. All right, well, I'm going to clean up my mess of tools here because I don't need these for the next project. The next one is going to be this detent. This is the lever, the valve, the spool for the main cylinder, and it has the auto retract. So when you put it there, it detents. And then when it reaches the end, the pressure from this bottoming out should cause this to go back automatically. Most of the time it does, sometimes it doesn't. I've had issues with it before. It always is just gunk plugging up these tiny little ports that are in here. So we'll take that apart and fix that. So this housing should not have any oil. I've had this apart enough, I should have this memorized by now, but there is a little port with O-rings that allows the pressure to be sensed by this assembly here, which has a spring in it. So I think this whole thing will come off with this last cap screw. Like I said, you'd think I would have this memorized by now, but I do not. Every time's a first for me sometimes. So this is the spool, the same one that the handle is operated by. This is that port that connects with here via an O-ring, and that's what seals it. So this in here, this chamber does not see any pressure. The only pressure is felt in there, and then we'll take this apart and show you how that works. So you can see this oil is not super clean, so it's just dirty. It's in this ball bearing. So this is in this, and there is a ball bearing that rests in this on top of this, and there's a spring. So how much pressure this feels, you feel the detent that is basically overriding the spring pressure, pushing this in up over this little hill, if you will, the ball bearing, and then into this groove. And then with the pressure port here, the pressure will be felt underneath here, and then it'll lift that up and then allow this to go back to center without having to move the handle. So that's how it's supposed to work. But I think what happens when sometimes it doesn't is that there's just some buildup between this port and in here, where this little piston, essentially a cylinder, can't feel the pressure to lift this up out of the way. So I'm just going to clean this out, put it back together, and it'll likely work, at least for a while. So taking this apart. So I think this is the actual cylinder that makes the seal, and then this just sort of rides on top. The ball bearing actually comes out of the bottom here. Well, it's the bottom here, but normally it's upright. So that ball bearing is in there, and it pushes up on here. So let me take this all apart. So yeah, this is the actual piston. So I was incorrect in calling this the piston. So you can see the O-rings, these little white things, I think are called either backup rings or wear bands. But it's the same idea as any hydraulic piston. So I've wiped this down and blown it off several times. It's actually in place. So now we'll put this ball bearing back in, so you can hopefully see there that like that. So there, I can push it, and it's in that slot. I can push it back out, so you can go either way with it manually, which is the same as using this handle. It actually goes this way. So you can see that perhaps. Ball bearing's there, and it's sort of in the detent. You can hear that detent, and now the spring is wanted to release the detent, and it will do that either with this fastened, which we'll do here in a second, or with the pressure, which would lift up on that ball bearing. The amount of pressure that is required for the ball bearing to be lifted up depends on the system pressure and also on how much preload is on that spring. So the more we tighten this down, the more pressure it's going to take to overcome the spring pressure and allow that ball bearing to come up out of that little ring in that detent. I never had an issue with this loosening up, but I guess it wouldn't be a bad idea to put like blue Loctite on it or something just to make sure it doesn't back off. So you can see none of this is under oil hydraulic pressure. See, this way there is no detent, only when you want to bring the cylinder back is the detent. And then you can release the detent manually or allow the pressure to do it if this is set correctly. So this top nut or bolt, whatever you want to call it, is the adjustment for the spring, and this is just simply a locking mechanism to keep it in place. So I can't operate it locally anymore because the resistance is in the lever here. So to give it some fuel, I have to do that. Well, it seems to me there should be a happy medium. As you hopefully could see, it was either releasing when it was like 800 pounds or so, or if I tighten this just a smidgen more, it would not release at all. It'd go up to whatever the relief pressure was, 1700 pounds, and just sit there. So I'm not sure, because I don't have a lot of experience with this. I'm just not that knowledgeable, but I'm guessing with it cleaned out, it'll probably be good for another year of operation before I have to mess with it again. But it is what it is, so everything seems to work well, and it's ready for action again. So the next project involves my log loading trailer and this tongue jack. So when I put this on, you can see how far it tilts like that. So I can't recall if I had welded this when I got it. I almost think I did, but it's cracked there, so I'll re-weld that. But the other thing I want to do is, it looks like it's elongated, which allows it to rack back and forth like that. So my plan is mostly for the top. I'm just going to cut the top maybe about halfway in, see if I can close that up and make this a little bit tighter, because that's right there quite a bit. Still a long way to go. It's actually now a bit narrow. Height-wise, it's probably still a bit loose. Maybe I'll just squish it that way and the sides will bend out a bit that way. This seems to be really mild steel. It heats up very easily and it seems to bend very easily, so well, I think what I might do is just weld this up
And then as I need to, there's just a couple places I think that are very close to fitting, is just file that down, or I could take a burr and round this out as well. So after a little bit more grinding and deburring, it's still pretty sloppy, but it's a lot better than it was. I'm not sure I'm going to get it any better, because there's not much of a gap around here, because any gap there is amplified. But yeah, the best case scenario would have been to replace this and replace that with sort of a matching set, but that's not in the cards. So the only thing I have to do now is just grind this crack out and re-weld it. Okay, so that's all done. Barely slips on there, but it is still a bit loose, but it's all painted. I reinforced the top there, as well as I re-welded that little bit there. So while it's hooked to the tractor, storage position is up here. All right, on to the next project. So the next project is to modify this thumb. This thumb came with the machine when I bought it. I don't know how many years I've had this, at least 5. It's a mid-90s E70B. This hydraulic thumb is very useful. I'm glad I have it and very thankful for it. It does move very slowly because the hydraulics are the same as the blade. So this is the hydraulic pump. These are the main pumps. There's 2 pumps. I'm not sure if it's a single pump that acts as 2 or if it's 2 separate pumps, but that's sort of the main functions of the unit. This little pump here is for the blade, and in the aftermarket thumb, this is also the pump for the thumb. So it's plumbed in. I'm not sure where the pressure side is plumbed in, but the return is plumbed in there. Okay, now I know, because I replaced the other valve. So the pressure side first goes to the other valve, and then it has power beyond. It may not be plumbed the best because you can't use both functions at once, sort of as an open center valving system. So the high pressure goes to the thumb first, and then this is the pressure side, and that's the valve for the blade. So this is OEM. This other little pump is for the pilot. So there's a pilot filter, and the pilot are all these small hoses here. That is what actuates the main valves for each of the functions. On the other side of the machine is the aftermarket valve for the thumb. I replaced this. I modified it a bit to make it operate easier. And I'm not a hydraulic expert. I'm not sure if I plumbed the power beyond correctly, but it works. Like I said, you can't use the blade and the thumb at the same time, but almost never do you want to do that anyhow. So this is the lever for the thumb. That's closed up, but basically that rod underneath there is what connects to this rod here. So it works fine. It's not the best thumb. One, because it operates slowly. I sort of refer to it as my hydraulically positioned mechanical thumb, because that's what it seems to act like sometimes. If I have the thumb in a certain position, I just soon do all I can with it in that position. You know, opening and closing this, like to grab brush, is not very easy. The other thing is the pivot of the thumb does not match the pivot of the bucket. So depending on the orientation of the bucket, depends on whether these teeth match up with that one or not. So you can see here, there were tooth holders that were welded on. This one busted off. I often have these teeth break off. I'm just not sure why they chose teeth for the thumb. It's generally not needed. I have a different idea. I am going to use teeth holders, but I'm going to use them instead of having, which is normally like say 3/4 or 1 inch wide plate, sort of cut into a shape like a tooth though. And these don't match up, and they don't cover the entire width of this. So the 2 things I want to do is make this so it matches up with the teeth. I want to figure out, you know, where to place these so that the position that I most often will use this bucket in, the teeth are matching with this, and that's probably going to be with the bucket almost all the way open. So I plan to use some scrap material I have over here. Hopefully I can find the right shape and enough of it to make some sort of a bracket to weld those teeth to. So the excavator has been really good to me. This was the first start I've had since fall, which would have been probably October, maybe November, I don't remember. It's a Mitsubishi engine. It always starts up like that. I've never had an issue with it starting, never really had any engine problems at all. The only significant issue I've had with this is 2 things. One is the final drives, which are aftermarket and they're relatively new. And the other is the rotary joint, which I think is what this is called. So for the longest time, the blade would drift down. The blade would not set up like that. You can sit here and watch it drift down once the lever was off. So that's what caused me to replace that other valve, knowing it was sort of connected in the same circuit as this. I had this valve rebuilt by a shop. They didn't find any issues with it. And then eventually I realized, oh, maybe it's the rotary joint. So what was happening is the seals inside this part that rotates, that separates these chambers, the O-rings or the seals were leaking, so that the blade always had a small path to the tank, which was allowing it to drift down. But that fixed it. Yeah. First thing I'm going to do is take the torch and cut these off, and then figure out how to weld something on here so that I can attach the my new teeth. So this is with the thumb fully extended. You can see this is, I guess it's more open than it is closed, but it probably still can go back. The tips of these probably go back to about here. But this is often the position I use when I'm grabbing log stumps, smaller rocks, as well as brush, as I'll have this fully closed. So I'm thinking this is probably the position where I want the meshing of the two teeth to line up the best. And actually it looks pretty good now, but I'll show you what I'm going to do in place of this. So I'm still going to use teeth holders, but I don't plan to put teeth on, just because I've not had good luck with these. So I'm going to use these instead of, having 1-inch plate cut out in the shape of a tooth. These are relatively inexpensive. They're weldable, obviously. So what I want to do then is have these teeth sort of about like that. And the other thing you'll notice is I want to have them all, between the teeth of the bucket, where this one doesn't and this one doesn't. So I just want to align these. So what I'm going to have to do, because I need to take up the length of this tooth with extra frame, I guess you might say, is I need to extend this down, so it's basically like here. So that's what I'm going to try to use my scrap for. This looks to be a 1/2-inch plate. I think I do have some 1/2-inch. I'm not sure how wide. I have some angle iron that I can probably finagle to do it as well. So this is sort of off center, and I don't know why. I'm guessing it was not built like this. Maybe something had bent over the years to sort of cause this to bend this way. But as long as I've had it, it's been like this. So I'm just going to redo the teeth so there's one in between each one. So this is going to look funny because this one is in the right location, but this one I'm going to have to move out just a little bit. So the teeth are going to be off center with respect to the frame of this. But I'm not going to try to rework it, and at this point I'm not going to put a new thumb on. I'll talk more about my sort of longer term, bigger picture plans with this excavator, as well as the dump truck that I purchased. When I have the dump truck here, I'll review that and then talk about my plans for all that. So I can see the little bit of the construction that looked to be a couple different pieces of metal. Obviously there's a plate welded on there. The front of this broke off when the tooth busted, but these I'll have to cut. But my intention is only to use this portion
to attach the new framework to, so I don't need to cut it all the way back here. I'll just cut it off flush there and cut it off flush there, clean up this, and go from there. So it'd be nice to have an air gouge. I think that's probably a better tool for this, but you dance with the girl you brought, I guess. So that's what I got, and that's what I'm dancing with. So I'll finish taking these off, and then we'll come back when this is all ready, and I'm going on to the next step. So that middle tooth is removed. I ground this. I'm having, I think I'm in the middle of a change of plans. I'm just thinking, I don't want to really spend a lot of time and effort on this thumb because it does have a lot of downfalls. I'm just looking for something that's just a little bit better than it is. And sort of along that vein, I'm just thinking instead of adding a bunch of framework to here, because these are positioned with the teeth on, they're actually positioned fairly well, and the bucket obviously can close a bit more. But I'm thinking if I was just to put these tooth holders, you know, in a better position, like right there instead of there, and right there, which didn't have one, and then this one will have to overhang. So I will have to figure out some sort of a structure there to hold that. But I'm thinking that would be a lot simpler, get the job done quite a bit quicker, less time and effort, a lot less gas, a lot less supplies, a lot less welding rods, and just do that. The other thing I noticed after I took this small one apart, I should have realized here, is this plate here, which I'm guessing was this entire plate here, was put in after these tooth holders were welded on, because these were deep down in here. So in order to fit these in, because I'm limited with the gap here, is that I sort of have to use this, you know, I have to remove this. So what I'm thinking I may do is just take this plate off. I don't know what the purpose of this plate is. It's obviously not that structural because it's rather thin compared to the rest of the stuff. So I'm thinking I'll just cut this off, and then I can cut this plate off wherever I need to put this, and then maybe I don't have to worry about cutting the tabs off here. If I was to leave this on, I could just put it and weld it up here like this one. That one. This one here is going to be over here anyhow, so I may have to clean up this edge, but I'll probably use that as part of the support for this one. I didn't plan it that way, but it just so happens these teeth holders appear to be identical with what's on here, which is really nice. Glad it worked out that way. Okay, so again, I'll clean this up. I'll get ready to put these on, and then we'll come back. So this plate's been removed and sort of cleaned up. This I don't need to remove because, as you can see, the other piece is going to go probably right next to it. This piece will go here, and this one here. So what I've done, because of the different hinge points, I want to make sure that from when the teeth first engage until it's this is open as much as it can, this is closed as much as it can, that it's still not going to interfere with the teeth. I think we're okay because this one appears to be rather centered here as well as down there, but just to make sure, I'm going to mark out sort of the opening to make sure that doesn't change, and if it does, and then this one is you're just going to go on the end. And if it does change, make sure that I stay within it. So hopefully that makes sense when you see this move. So it didn't appear the orientation did not appear to change much with that rotation. So I'm just going to center it between the marks.
So as you can easily see here, I have to figure out a way. That's weird. I don't understand the triangle shape. But anyhow, figure out a way to cut out this, but not that. So I'm not sure if I should continue to use the torch and cut it out that way. It's a lot quicker. Or if I'm better off using grinder. What I think I'll do is just torch it, because I think I don't need to take off as much, because you can see there's quite a gap there. So I think I'll just use the torch and just sort of eat away at that corner until this slips on all the way in. Getting close. I don't think I have to go all the way back. I don't think the other ones did. And what I'm more interested in is these holes lining up. I still have to go a bit more. I may grind some and see if, because this I think is okay. I just need to increase the angle, and it's probably easier with a grinder rather than a torch. Well, that actually worked surprisingly well and was surprisingly easy. So I measured basically from trying to use this as a datum, a reference point, to the center of this elongated hole. 1 3/4 what it turned out to be. And the same thing here, I actually have to move it out just a bit to get that same 1 3/4 from this datum to the center of that elongated hole. So I'm good. So let's just repeat the process here and then figure out what I need to do here. So for this end piece, I did have 2 pieces of 1/2 inch thick. It's by 2.5, which I think is going to work out to be the right width. You saw me cut that in half. I had a piece that was about 9 3/4 long, so I just cut it in half. I'm going to offset it because I'm going to have to etch away some of this anyhow, grind or cut away some of that to make this angle. But my challenge is how I'm gonna weld these together to sort of make them like they're one unit. I may even drill a hole there and sort of do I think it's like a button weld or something like that in the center, but just sort of cantilever out here. Do something like that. This will be towards the end, I think, to be centered like that. So I have a lot of unsupported weight here, or unsupported distance. So I'll probably have to put some reinforcement bar like that way. We'll see, maybe even something to connect these 2 teeth holders. So this is my mag base drill, and I have just enough length on that piece. If I was thinking, I would have drilled this before I cut it. But it's enough there to hold it to drill a hole so I can weld this piece. So that's what I've got so far. I welded both ends, this one and the other one. Underneath here, there's that button or plug weld. I'm going to have to grind that flat. But for now, I want to grind this surface so it fits in there. I also ground some grooves in here. So I'll use 6011, which is a better penetrating rod than 7018, to put probably one pass on this side, because that will be flush with this. My bucket is drifting down, that's why it's so low now. The outside edge I can build up, because that'll just sort of be on the outside of that. So I'll do some grinding and we'll come back. Alright, I think I have this thing ready for mounting, mostly. So this is just sort of set in place. Not that it's critical, but it does look as though these oval holes line up pretty well. The exception is this one here might be a little bit low, but there's nothing really that says these have to be in line. It's just really how evenly they're going to hit between the teeth here, and there's a lot of variation there too, so I'm happy with that. It turns out that this edge here is a little bit back further, but there's a similar amount of space between all of these. A little bit more here obviously, but I think that'll be fine. So on the top side here, I want to gouge out or make a bit of a groove here so I can have a nice weld that goes a bit deeper in. I have a nice shelf there for a little fillet weld. Underneath here, I think there's already enough of a gap here just because of the wear on this thing. And right there you can tell there's quite a gap, so a nice fillet weld there. So I think the only thing I have to do here to prep welding this on is just grind this out a bit more so I can penetrate maybe quarter or half an inch into this, which ended up being a 1-inch thickness. So this is the outside. This pass here to join the two pieces of 1/2 inch, there's a center 6011 pass, sort of a root pass, and then two passes that overlap of 7018. This side here, I only had was able to put one pass in of 6011 because I needed to grind that flat so it meshed here. All right, so I've got this all clamped into place and it's prepped for welding. I will tack it in place and then probably put at least one or two passes in, and then I'll come back and take a look. So the root pass is done all the way around. This is the best orientation I could get. I'd rather do a vertical weld than upside down. But the 6011 doesn't, at least for me, doesn't come out as smooth, but it seems to penetrate nicely. I think it's still a good solid weld. The 7018 will look a lot smoother. So we'll do that, and then when it's all done, we'll come back. Still got to figure out what sort of a reinforcement to have here. Well, I think I have a good reinforcement, but I don't know what happened here when I marked that little notch out just to sort of avoid the corner of that. But I'll try to do my best to fill it in with weld. It shouldn't be that difficult. So same sort of thing, I'll do a root pass with a 6011 and then finish it off with a 7018. Well, it doesn't look pretty, it'll work. It looks peen because I used the needle gun to scrape off the slag, since I really can't fit my wire brush or my wire brush wheel in there very well. So let's get that sort of ball peened look. I was able to fill in that gap there fairly easily. So I've got this one marked out. Basically it's going to be just at the end, just like that. So plenty of room there for a fillet weld. And that's the next thing, is to put all these in. So same sort of thing. Probably grind a little bit of the paint off, but the 6011, the paint doesn't really bother it. It'll just burn off. Tack these, or do the root weld with the 6011s, and then pass it over with the 7018. Over here, I did not do this fillet here because I figured I would just do that after this is in place, since this will probably be welded to that. I think this will provide plenty of support. So the issue here is when this clamps, whether it's clamping on a log, a rock, the ground, a stump, or whatever, this outer tooth is going to want to push up. So that's what this this strong back or gusset is supposed to guard against. And, I should also be able to help myself by probably filling in a fair amount of this here so that it doesn't have the chance to hinge at that joint there. All right, update time. So these are all welded in. I did end up putting a little bit of a gusset here. It's just a welded mess here, but you can see all the pop marks from the needle gun to take off all the slag. But I think that's going to be rugged enough with this cantilevered out like it is. And I was thinking, this piece that I cut off earlier that I wondered, why is this piece on here? It was, might have been 3/16, quarter inch at the thickest. But I'm guessing it was to prevent the middle from sort of bending up as pressure was put in the center one. Because now I don't have a center one, I have ones that are sort of closer to the main frame. But I think it's easy enough just to sort of duplicate that. I don't need to go down here. It doesn't have to be welded solid. I just want to support this center to resist that moving up. So we'll do that. While I was poking around, I noticed I did have some cracks along the tooth holders for the main bucket, so I welded those up. And I do have new pins. I'm guessing these, the slot or the groove that the washer sets in have probably worn out. So I'm going to replace all those because I don't need to be losing bucket teeth. So we'll do those things. I have these. I'm going to put these all back on. In fact, I have 4 of them, which is nice. We'll talk about the keepers later, but the keepers that are meant for this style pin I have not had good luck with, at least in the application of being on a thumb, which I've said is sort of unique for bucket teeth, but it is what it is. So instead of using the keepers, which not had good luck with, I'm just going to put in 7/16 grade 5 bolts. I looked for the nylock nuts. They did not have any in stock, so I'm just going to put regular nuts on and just tack them with a welder and leave, so I can leave the bolts themselves loose to sort of duplicate what a what a pin, a keeper might look like. So since we were talking about welding and these types of teeth, I thought I'd look at one of the old ones, one that broke off. So you can see here, this broke off. But it's interesting looking at the welds. It looks as though the only weld that penetrated was this one along here. This one here doesn't seem to have penetrated. It's just like it just sat on the surface of the, the framework. Get that in better focus. There we go. So you can see the broken part there. You can see the weld, which appeared to penetrate a little bit. But then you can see these other welds here, which seem to just set on the surface. It looked like it adhered well to the holder, just not the frame. So as far as the type of pin that this one typically uses, this is what's left of it because it's bent. But you can see here there's a little bit of a shoulder, and this is rubber, what's left of it. These are normally fixed like this, and this goes in here. And the rubber compresses, and then when the rubber, when the pin goes all the way through, the rubber will sort of, make this little shoulder stick out there. And that's what holds it in place. But for whatever reason, this gets moved around, probably a lot of sideways, a lot of forces in the direction that it's not really intended for on a thumb. And these things seem to slip out.
and they just don't hold, and I'll often lose a tooth.
So I think the biggest issue with these is not so much the retainers but the pins. So you can see the difference here, hopefully. The edges just get rounded off and they can easily slide beyond the keepers. So here's a keeper or a washer. It's split so it expands when you push it in, and then it shrinks when it gets into that little groove there. So these, I have two different style new ones. I don't remember how or why I got them, but some have this plastic. I guess it's just sort of a washer retainer, just to help it stay in there, because this has to stay in there while you put the tooth on. But then there are other new ones that I have that don't have that, but they serve the same function. Pretty inexpensive, certainly less expensive than busting a tooth. And this one actually busted off. Looks like it busted off right there. That was the furthest one here. So they do make a special tool with sort of an offset punch. I just bought a big punch here, and I just sort of hollowed the end out so that it more easily fits in there, because I'm going to be pounding at a little bit of an angle. So I have to go like that. So that it always goes in this way. So if you pound it in this way, most of the way in, it'll go, you're just pushing it, and then you just have to tap it in a little bit, and then the opposite way to push them out, because once you get past here, you can sort of pull them out by hand. Well, that went in harder than normal. There. So you can tell it's all the way in when it's sort of loose like that. So there's actually quite a bit of play in there between the pin and the washer. But they're not supposed to be tight. You're supposed to stay on there. The end one's always my favorite because I don't need the punch. So, they are now all in, as they should be. I always like to have a spare set of pins and washers, so I'm going to have to order some more. But these are, I can't remember how much they are, but they're pretty inexpensive. Alright, now with my unorthodox thumb teeth. So I'm not going to tighten these with a wrench, I'm just going to hand tighten them and just tack a little weld on the end of the nut to make sure it doesn't come off, but it's going to be basically just as loose as the bucket pins. Well, I think that should hold them. Yeah, it looks pretty ghetto, doesn't it? Well, functionality is what I'm after. We'll find out this summer if it's going to hold up and if it's any better than it was before. Well, that is done. I was thinking about this. I didn't measure it, but I'm almost thinking maybe the bucket is off center. It's not the thumb at all, which could be problematic because now if I have another bucket that's actually center, then oh gosh, now's a great time to figure that out. Okay, well, I had thought I was going to have time to review the equipment and method that I use to record these videos. I've had a couple people interested in that. I thought I could tag that on to a video that's otherwise rather short, but I think this video is a bit longer than I was anticipated. So I will include that in an upcoming video, I promise. The equipment that I use, methods that I use to record myself, and the editing software that I use. But for now, I appreciate you watching these projects and hope you stay tuned for more. Thank you.